In this lesson, we are going to talk about law of sines, the ambiguous case. So there's law of sines and law of cosines are your two options of what you can use to solve a triangle that's not a right triangle. Law of sines has a tendency to be a better option than law of cosines. It's just a little bit more straightforward, a little bit easier setup. So because of that, it seems like there is an asterisk to this, that you have this thing called an ambiguous case. There's this potential that given a certain situation, you have this potential for more than one correct triangle. And that seems weird, like how is that a possibility? And the only time that this is a situation is if you are given a side, side, and an angle. So here's what it looks like. So if you are given a side, side, and an angle, side, side, if you're given that situation, there is potential that you can draw this picture twice. So my suggestion, my recommendation is draw this exact same look no matter what the letters are. Don't turn your picture, don't do anything, because one of these sides, and this one across from the angle, is going to potentially pivot and create two different triangles. But if you turn your triangle all sorts of different ways, you're going to have a hard time seeing which is the triangle, which is the side that turns. So personally, I draw it a certain way every single time, and I could care less about the letters. It helps me to kind of at least get the thing set up. So here is kind of your situation. All right, and so here's how my picture looks, that I draw this. And on purpose, I don't finish that side, because that's the side then it tells me that it could pivot and create two different triangles. So I'm going to call this angle A, which makes this side A, and I'll call that angle C down here, angle B, and side B. So what we're going to have is, oh, that's B. Oh. Oops. All right, sorry, we're going to call that side C. So angle C, and then, okay. So those are the three pieces that we're going to have. So we're going to have side, side, angle. So here are your situations, and then we'll have a visual of what the heck's going on with this. A is your swing, so that is one that you got to keep in the back of your mind. That's the potential that it's going to move. So first situation is, step one, is if A is greater than or equal to C. So if that is as big or bigger than this piece, then one triangle, no matter what. Okay. If A is smaller than C, A is less than C, then you got to do some work. Then you have to compare. Compare A to the height. What we mean by the height is, we mean the height. Now we don't know the height. We got to figure out the height. That's the key, okay? So you're going to have these different scenarios based on how this piece compares to this piece. Is this piece bigger than this piece? Is it equal to this piece? Or is it smaller than this piece? All right, those are your three different situations. So we'll come back to in a second of how we figure that out. First, let's talk about the why. Why on earth is that even a thing? So here's what you got. So here is our visual. So this is the side that we know. So that is C. This is A. Didn't work like I thought. And then this is side A over here. So this is the piece that potentially, if it's just the right size, kind of the Goldilocks thing, that this thing is going to potentially pivot and hit twice. Because what you don't know is, you know this angle, but you don't know how long this piece is. It could be this long, or it could be this long. We have no idea. And then our other issue is, we don't know how big that angle is, and we don't know how big this angle is. The only thing we know is this piece is locked, this length is locked, and that angle, this gap, is locked. So it could be here, or it could be here. That's why the ambiguous case exists. All right, so that's why I leave it and say, there's potential that it swings. Could be here, could be here. So if you have the right situation, you're actually going to create two triangles, and we got to do the work to figure out those two triangles. All right, so that's the work, that's the description that we're going to talk about here. So your scenarios is it's kind of a Goldilocks thing. Is it fit in this perfect range here? So so here's your situation that if your A is greater than the height, then two triangles. And that's your Goldilocks. If that thing fits somewhere between this value and this value, you're going to have it swing and it's going to create two triangles. If A is equal to the height, then you have one right triangle. It's actually a right triangle because if it's the height, it is a right triangle. All right, so then actually you're don't need law of sines at all. You can just do SOHCAHTOA kinds of stuff. And then your third situation is if A is less than the height, then no triangle. Because it's not even long enough. So it's actually too short that the minimal that it has to be is at least got to be as long as whatever that height is. Otherwise it kind of rotates and it never hits anything at all. So those are your situations. But how do you figure out the height? That's the last piece. Well, actually, you can look at it like this. If you ignore this, and you're just kind of talking about this right triangle, how do you figure out the height? Well, you would use sine. So sine of A, because we would know this value, and we're looking for this value. So sine of A is going to be opposite over hypotenuse, and we solve for h. So we multiply the c over, so our height is always going to be this c value times sine of your angle. So that's what your height is always going to be referring to. All right, so in other examples, we're going to talk about all the different situations, throw numbers in them, but this one just wanted to kind of define everything. So the very first thing is you're looking for, do you have a side-side angle situation? Do you have this look to it? And then second thing is we got to compare. If this value is bigger than this value, it's one triangle, business as usual. If this value is in between this opposite value and the height, which you have to find, then you're having kind of the Goldilocks situation where you have to, it swings and it makes two different triangles. If it's equal to the height, it's going to make one right triangle, and if it's smaller than the height, it's too short and doesn't connect at all. All right, so we'll do a couple examples after and other videos to do certain situations.